In this video, I will be talking to you about Euclid's theorem. Now, before learning about the theorem, let's learn who Euclid is. Euclid was a great mathematician who lived more than 2000 years ago and spent most of his life in Alexandria, Egypt. He wrote many important books and made great contributions to mathematics. One of his most important books was called Elements, which is a book that is still used today to teach mathematics to students all around the world. He developed theories about space, time, shapes, and geometry, and because he spent most of his time on geometry and made great contributions to geometry, he is also known as the father of geometry. Now let's get to the actual theorem. What is the Euclid theorem? For example, let's take a right triangle and also draw the height of the hypotenuse. Now let's label the sides as C, P, Q, H, B, and A. Now according to the theorem and Euclid, these four formulas are concluded, which are h squared is equal to p times k, c squared is equal to p times a, b squared is equal to k times a, and the last one is a times h is equal to b times c. In our next step, we are going to explain the Euclid theorem using similarity. Similar triangles are triangles that have the same angles but different side lengths. Here are the angles which are the same in our figure. We labeled them as x and y. As we can see from the figure, we have three similar triangles according to their angles, which are the triangles HBA, HAC, and ABC. These similarities will help us explain the theorem. For the first formula, we are going to use the similarity between triangles HBA and HAC. We know that if two triangles are similar, the ratio of their sides are equal as well. So for this formula, we are going to use the ratio between the sides across angle y and angle x. If we find the ratios for both triangles, HB divided by HA is equal to HA divided by HC is concluded. And if we represent this with the letters we assigned the sides before, P divided by H equals to H divided by K is concluded. And if we do the cross multiplication of this equation, we end up with the first formula of the Euclid theorem, which is height squared equals to P times K. For the second formula, we are going to use the similarity between ABC and HBA. We are going to write the ratios between the hypotenuses and the sides across angle y for this formula, which is AB divided by HB equals to BC divided by BA. Now if we represent this equation with the letters we have assigned to the sides, it becomes C divided by P equals to A divided by C. And if we do the cross multiplication once again for the equation, we conclude with the second formula of the Euclid theorem, which is C squared equals to P times A. For the third formula of the theorem, we will focus on the similarity between triangles ABC and HAC. We are going to take the ratios of the sides across angle X and Y and we will write them down. It will be AC divided by HC is equal to BC divided by HC. And if we represent the equation with the letters assigned before, it will become B divided by K equals to A divided by B. And once again, if we do the cross multiplication of the equation, it will give us the third formula of the theorem, which is B squared equals to K times A. And lastly, for the fourth formula, we are going to explain it using the similarity between triangles ABC and HAC. We are going to focus on the ratios of the hypotenuses and the sides across angles X for this formula. If we write the ratios of the sides, it becomes AB divided by HA is equal to BC divided by AC. And if we represent it using the letters we have assigned before, we conclude with C divided by H is equal to A divided by B. Then, once again, if we do the cross multiplication for the equation, we end up with the fourth formula of the theorem, which is A times height is equal to B times C. Now, to finalize the explanation of the four formulas of the Euclid theorem, we must always remember that for the Euclid theorem to occur, we must have a height drawn to the hypotenuse of the large right triangle. And if we don't have a height drawn to the hypotenuse, then these formulas won't work. And we must always remember that these formulas come from the similarity between the three triangles represented in the figure. So, in the next step, we are going to do a few example questions using the theorem. Example question 1. For the ABC right triangle, angle BAC is equal to 90 degrees and AH is perpendicular to BC. If AH is 2 root 6 and BH is 4, find HC and AC. Now, to find the answer, we must first label the sides with H, P, K, C, and B, and A. And to find HC, we are going to use the formula height squared is equal to P times K. And if we put the values in, it will become 2 root 6 squared is equal to 4 times K. And then 2 root 6 squared is equal to 24, which is equal to 4 times K. And if we divide 24 into 4, it will give us the value of K, which is also HC. We know that K is equal to 6. And to find AC, we are going to use the formula B squared is equal to K times A. So if we put the values in, it will become B squared is equal to 6 times 10, which will become B squared is equal to 60. And if we find the square root of both of them, we will find B, which will be root 60. And if we turn root 60, if we simplify root 60, it will become 2 root 15, which is the value of AC. Example question 2. In the triangle on the left, AB is perpendicular to AD, AF is perpendicular to BD, CE is perpendicular to BD, and CB is perpendicular to DC. If AF is 12, BF is 8, and ED is 4, we must find CE. Now, to find CE, we must first of all find FE. So, we will name FE as X and solve from that point. If we name FE X, to find FE, we must use the triangle ABD and the formula height squared is equal to P times K. If we fill in with the values, it will be 12 squared is equal to 8 times x plus 4. Now, why is it x plus 4? Because the K in this situation will become FE plus ED, which will be x plus 4. And if we continue with the equation, it will become 144 is equal to 8 times x plus 4, and if we divide 144 into 8, it will become 18 is equal to x plus 4, which will give us the value of x, which is 14. Now, using the value of x, we are going to find CE, and we're going to use the triangle CDB and the same formula. So if we put in the values, it will be CE squared is equal to 8 plus x times 4. Now this time it's 8 plus x because k in this situation will be the sum of sides BF and FE. Now if we put in the value for x, it will become CE squared is equal to 8 plus 14 times 4, which will be CE squared is equal to 88. And if we take the square root of both of them, it will be CE is equal to root 88. And then if we simplify the root, we will find CE as 2 root 22. Example question 3. What is AH? So to solve this question, we must first use the Pythagoras theorem to find BC. And from that formula, we will find that BC will be equal to 10. And then we will use the Euclid theorem to find AH. So we will use the fourth formula of the theorem, which is AB times AC is equal to AH times BC. So if we put the values in, it will become 6 times 8 is equal to height times 10, which means that height is equal to AH. It will be 48 is equal to H times 10, and from this equation we will find that height, which is also AH, is equal to 4.8. So before doing this project, I always thought that the Euclid theorem was about memorizing the formulas and nothing else. But after doing this project, I realized that there was actually a meaning behind this theorem, and we could explain it using similarity between triangles. Uh, this project also helped me by making me revise my similarity knowledge from the years before. One specific thing I could have done better was that I could have planned my project uh, in a better way in the beginning of the year when I chose this project. Uh, Other than that, I really enjoyed doing it.